from 0 to pi over 2. Okay. What's the sine of pi over 2? 1. And the sine of 0 is 0. This equals 1. Got the idea? These aren't so bad. This is just like when you do derivatives. You said, great, why did I do all that weird stuff? You say, well, now you understand it. Okay? So I showed you how to do a bunch of these indefinite integrals before, but let's practice a couple. These definite, sorry. So this is called a definite integral. So an indefinite integral is when you do the antiderivative with the plus c, and the definite integral is when you plug in the numbers. For example, now, you write a little dx there when you do integrals. Dx has a purpose. For now, just sort of remember that it's there. It's kind of like when you took a derivative, you had dy dx sort of peers, okay? When you do the integral, you have the dx, which stands for the fact that there's a derivative inside, and when you integrate it, it disappears. So this is called the indefinite integral. So this would just be x cubed over 3 minus 3x squared over 2 plus c. Notice the dx is now gone. Okay? In the process of integration, that you get rid of that. You're going to need that dx for stuff, which we'll see maybe next week, certainly the following week. Okay? And if I wanted a definite integral, let's say I was going from 1 to 2, by the way, why is it called indefinite? Well, because there's an infinite number of possibilities. It just depends what you pick for c. Okay? So far, so good? So the definite integral is the same antiderivative but now I'm going to evaluate it from 1 to 2. So I'm going to plug in 2, I'm going to plug in 1, and I'm going to subtract. So this would be 2 cubed over 3 minus 3 times 2 squared over 2 minus, 1 cubed over 3 minus 3 times 1 squared over 2. And you can figure out what that is. I don't really care. It's messy, okay? But you can figure out what that is. I'll leave the fractions to you guys. You're all going to be doctors. You'll be excellent at this stuff. Let's practice a couple. Make sure everybody's good at this. Okay, let's dig into that one. Alright, so we're going to find the integral from 0 to 3. You always say from the bottom to the top of x cubed minus 6x dx. So this is x to the 4th over 4 minus 6x squared over 2, which is 3x squared, from 0 to 3. So if you plug that in, you get 81/4 minus 27 minus, that part's just going to come out 0. Okay, and if you do this, you should get minus 27/4 or minus 6 3/4. So how can that be negative? Well, this is giving you the area under the curve. And what's happening is, so let's see. Basically, the curve's doing something like that. Okay? That's not 6, I'm sorry. That's the square root of 6. And 3 is somewhere here. So this area underneath is bigger than that area above. So this is another thing I was going to tell you about. So this is what's called signed area. So the area above the x-axis, but under the curve, comes out positive. And the area below the x-axis, so kind of above the curve, comes out negative. The negative part turns out to be bigger than the positive part on this curve. Okay, on this area. So for example, suppose we look at our favorite function, sine x. What do you think we would get if we did the area from 0 to 2 pi? We should get 0, okay? Because the part above the x-axis should cancel with the part below the x-axis. So let's do that integral. Do the integral from 0 to 2 pi of sine x dx, we get minus cosine x from 0 to 2 pi okay. Cosine of 2 pi is the same thing as the cosine of 0. So you get minus 1 minus minus 1, which comes out 0. So that's what we'd expect. So by the way, sometimes on these kind of calculus problems, if you know what the graph looks like, you can just get right to the answer. You don't even have to do the evaluation. Okay? So sometimes by symmetry or by knowing the geometry of what's going on, you'll be able to get to an answer very quickly. Let's do another example of that to see what I mean. So I want to do the area under y equals x, f of x equals x, from 0 to 6. Well, what does that look like? That's just a triangle, right? Y equals x is a straight line, goes from the origin, it'll go to point 6 comma 6. So the area would be 1/2 base times height. You get 18. Now let's make sure that our calculus agrees. So if I did the integral from 0 to 6 of x dx, okay, that's x squared over 2 from 0 to 6, which is 6 squared over 2 minus 0 is 18. That's exactly what we thought we were going to get. Okay? So sometimes you should be able to look at this and figure out exactly what the area is. Other times it won't be so easy. Let's just do a couple more, make sure everybody understands everything. That looks unpleasant. How about that? Let's see. Okay. So to do the integral from 1 to 9 of 2t squared plus t squared radical 2 minus 1 all over t squared. Now, of course, t, x, the letter doesn't matter, right? So you can do that one. And covered with chocolate.
Is that square root of t?
Alright, I'll say that. It's the integral from 1 to 9. Top is 2t squared plus t squared times the square root of t minus 1. All over t squared. So, how do you do this? Well, first of all, you're going to want to break this up. Integrand, as it's called. You do the integral from 1 to 9 of 2t squared over t squared plus t squared radical t over t squared minus 1 over t squared dt, which then simplifies the integral from 1 to 9 of 2 plus the square root of t, which is t to the half, minus 1 over t squared, which is t to the minus 2, dt. To get to this stage, yes? You wanted to bring the t squared up and make it t to the minus 2, but you'd be distributing it, you'd end up in the same spot. So it's unnecessary work, but sure, feel free. But you know, it's sort of doing it the hard way. But that doesn't stop lots of you guys. Okay? Generally, you want to do this as efficiently as possible, but you don't have to. When you see multiple things on top and one thing on the bottom, usually we do that to confuse you and see if you're clever enough to break them into the individual things over the denominator. Okay? So we do it the other way on purpose. Alright, what's the integral of 2? It's going to be 2t. The integral of t to the 1/2 is going to be t to the 3/2 divided by 3/2. The integral of t to the minus 2 is going to be t to the minus 1 over minus 1, all evaluated from 1 to 9. Or if we want to simplify that, it will be 2t plus 2/3 t to the 3/2 plus 1 over t from 1 to 9. So far, so good? Loving this? Glad I got my microphone back. I got an email Monday night from the audio-visual people. I guess somebody actually comes around at the end of the day and closes things up and said, the microphone is missing from your classroom. One of you people is bad. So I emailed back and said, well, at 4 o'clock it wasn't here. So I got the very nice email saying, thank you. Now we've narrowed down the suspects. So I guess they found the person. They probably killed him or her. The head is probably mounted outside of the SS now as a lesson for those of you in the future. Just to serve as an example for the others. Alright, we plug in 2. We get 18 plus, square root of 9 is 3. 3 cubed is 27. 2/3 of 27 is 18. Plus 1 over 9. Minus 2 plus 2/3 plus 1. So that's 36 and 1/9, right? 36 and 1/9 would be 325 over 9. And that's 3 2/3, which we could turn into ninths. And that would be 33 ninths. And that gives you 292 over 9. Am I close? I don't know. Yeah. 32.44. How'd I do? Do I get to go to college? That's why I stand in the front. Alright. So, I'll screw those up though and you'll get a chance to laugh at me. I promise. It's your third time around. You should know by now, right? Yeah, you. You've seen me do this before. Okay. Let's give you one more of these. Let's give you a really entertaining one. These are really fun, aren't they? Much less painful than the other stuff. Good. I'm going to make it painful now. Okay, who needs more time? You should be able to do that in your head. Got it? What's the answer? Yeah, you should be able to do it in your head. Who needs more time? Everyone? Good. What's the integral of e to the x? E to the x. That's the easy part. No plus 3. Okay, so this is e to the x. See, we can hit you with the logs, so you gotta be careful. That's e to the log 5
cancel out, right?
minus e to the log 3. What's e to the log 5?
5.
5.
Yeah.
E to the log 3. There you go. That wasn't hard. You should be able to do that one in your heads, as I said. All right. E to the log of 5 is 5. E to the log of 3 is 3. Right? Okay, make sure you know that. E to the log x is x. ln is pronounced log, or log.
You mean natural? Ln or log?
Okay, let's give you a more serious one. I'm looking for ones in the book. Ooh, this is painful. Then I'll go back and do some other stuff. I think I'll give you guys about 3 of them to practice right now. Good. Once you guys get good at these, there's 3 to work on. Alright, so, first one says, this one says the integral from 0 to 2 of y minus 1 times 2y plus 1 dy. This one says the integral from 0 to pi over 4, secant theta, tan theta, tan theta. I think you can read that one. This says the integral from 1 to 2 of x cubed plus 3x to the 6th all over x to the 4th. Okay? You'll read those? Okay. Let's do these. So how do we do the first one? Well, what I would do first is I would FOIL this out. So this is 2y squared minus 2y plus y is minus y minus 1 d1. You all multiply that out correctly? Okay. That becomes 2y cubed over 3 minus y squared over 2 minus y from 0 to 2. which is 16 thirds minus 2 minus 2 minus 0, which comes out 4 thirds, 4 thirds, right? As they say in the South Shore, 4 thirds. Alright, that was easy. What is the integral of secant theta tan theta? Secant theta. Because the derivative of secant theta is secant theta tan theta. Just going backwards. So this is secant theta from 0 to pi over 4. Now comes the fun part. What's the secant to pi over 4? If you don't know, okay, at least on your exam, write secant to pi over 4. Get yourself some partial credit, okay? You might even get full credit, depending on who the professor is. The cosine of pi over 4 is radical 2 over 2. When you turn it upside down, you just get the square root of 2. Okay? So that one comes out square root of 2 minus 1. Or if you do it in your calculator, it's about 0.414. Okay? Why is the secant of pi over 4 radical 2? Well, you take radical 2 over 2 and you turn it upside down, you get this, which is equal to that. You're not sure, cross multiply. Okay? You're confused? You know what cosine of pi over 4 was. It's 1 over the square root of 2. Good, what do you get when you turn that upside down? Square root of 2. Well, it's also that. Both. It's 1 over square root of 2 or square root of 2 over 2, depending on who your teacher was in high school. Use that triangle. Okay. As long as you get the right answer, that's what matters. Some of you memorize unit circle. Some of you still sort of do it in your head. I could put that back up on my Insta. It's on the Insta already. Yeah. It's in there. That stuff's over there from last semester. I could delete it and put it back. You could rewrite it. I'm the only guy who puts up math equations and gets 100 likes. I don't know what that says about my life. But what gets the most likes? Bonnie. Hello? The puppy pictures. Yeah. She's a little older than that now, though, so it's kind of sad. Okay, so we could break this up, and we could make this integral from 1 to 2 of x cubed over x to the 4th, which is 1 over x, plus 3x to the 6th over x to the 4th, which is 3x squared dx. That equals natural log of the absolute value of x plus x cubed from 1 to 2. We don't really need the absolute value because the absolute value of 2 is just 2. But you can write it if you want. And you get log 2 plus 8 minus log 1 plus 1. What's the natural log of 1? 0, because the log of 1 is always 0. So you get log 2 plus 7, or about 7.7. Got the idea? So one of the fun things about these antiderivatives is they stand for the area under a curve. Okay? But integrals also have other meanings. Okay? An integral generally is just a sum. So how many of you have taken physics? Good. So you should start using integrals in physics. Okay? It can get really hairy when you get into physics 132. 132? No? 126? Physics 127? Yeah, you'll see it in there. Yeah, that's good. Who do you have? Who do you have for 127? What professor? Oh, Linwood Lee. He's been here a long time. But I've been here longer. He came here in 1965. But I came here in 1961. Of course, I was a baby, but Professor Lee has been teaching here a long time. He used to be the tennis champion at my tennis club. I used to play him when I was your age, and he was my age. The age I am now. So, anyway, how's he doing? He's fine. Okay, good answer. Don't want to get yourself in trouble. You're worried about calling up and telling me. I would never do that. We're like, this is secret. Nobody even knows what we're saying right now. No, it's not like it's being recorded. All right. But if you're doing physics, you learn that there's displacement and there's distance. So displacement is the change in your position. Where were you when you started and where are you when you finished? So physics, they love to ask questions like you get up in the morning, you drive to school, you stop and get a bagel, you go out to lunch, you come back to school for a little while, you go to your job, and you come back home. What's your net displacement? Your net displacement is 0, because you're back where you started. But the distance is that whole route, okay? So integrals can be used to find either displacement or distance. For displacement, it's easy. For distance, you have to factor in that you might be going different directions at different times. So suppose we have an object that moves along a line, and we're given that the velocity at any time t find the displacement SS15 if you can't read it. Find the displacement in the first 6 seconds. In other words, what's the total displacement from time t equals 0 to time t equals 6? So all you would do would be to integrate from 0 to 6, t squared minus 8t plus 15. If you integrate velocity, you get position, okay? Because if you take a derivative of position, you get velocity. So if you integrate that, you do the antiderivative, you can figure out how far this thing has gone. Okay? So that comes out t cubed over 3 minus 8 t squared over 2 plus 15t from 0 to 6. That is equal to t cubed over 3 minus 4t squared plus 15t from 0 to 6. That is equal to 6 cubed over 3 minus 4 times 6 squared plus 15 times 6. That's the first one. The second one, when you plug in 0, you're just going to get 0. You can ignore it. Minus 0. So let's see, that's 162 minus 144, it's 18. Okay? So that's the net displacement of this object from time t equals 0 to t equals 6. Here's the fun thing, since often you haven't taken physics. Velocity is a vector. What that means, to put it in simple terms, is if you go in one direction, it's positive. If you go in the opposite direction, it's negative. Okay? So you could say, for example, to the right is positive and to the left is negative. Up is positive, down is negative. It doesn't really matter. Okay? But there's a difference between going this way and this way. So this object has velocity t squared minus 8t plus 15. If you factor that, when you put that on a sign number line, remember this from last semester, and then you found the value of velocity, you find it goes like this. Which means the object is kind of doing something like that. So until you get t equals 3, it's going to the right. Then it turns around and goes to the left until t equals 5. And it finishes somewhere around there at t equals 6. Okay? So notice, part of the time it's going to the right, part of the time it's going to the left. And then we found that displacement is this. It's where you started versus where you finish. Okay? This is actually on the x-axis. So the displacement we said is 18. So you're 18 units away from where you started. But the total distance traveled is not going to be the same. To the distance, you have to break up the integral. Because when it's moving to the left, you get negative values, and you don't want to subtract those off when you're doing distance. So if we were doing the distance instead of the displacement, we would need 3 integrals. We would want to go from 0 to 3 of t squared minus 8t plus 15. And then, because we're going to the left, we would want to subtract the answer we would get from 3 to 5. And then we would add from 5 to 6. Does that make sense? It's just a little more tedious, obviously. Okay? Yes? I'm subtracting the second one because velocity is negative. I would get a negative answer, and I want to make it positive. Correct. Okay? That makes sense? So the simple rule you say to yourself is, wherever velocity is negative, I just subtract the integral. I know most of you are not taking physics, but we get to do this in 126 anyway. So you want to break up the velocity, find out when it's positive, find out when it's negative. So let's just do one. Something nice and easy. There we go. Find the distance traveled in 5 seconds. You love math? So first thing you're going to want to do is you're going to want to factor that incredibly difficult quadratic, t squared minus 4t plus 3. You factor that, you get t minus 3, t minus 1 equals 0. So far, so good? You go to number line, and you should get that. Okay, now if we want to find the distance this thing has traveled, we're then going to need 3 integrals. We're going to do the integral from 0 to 1 of t squared minus 4t plus 3 dt minus the integral from 1 to 3 of t squared minus 4t plus 3 dt plus the integral from 3 to 4 t squared minus 4t plus 3 dt. How are we doing this part? Oh, I said 5 seconds. Sorry, 3 to 5. Okay? So far, so good? If you break it up like this, that should be worth some partial credit. Okay? Alright, let's do the antiderivative. So we have t cubed minus over 3. T cubed over 3 minus 2t squared plus 3t. From 0 to 1. Minus t cubed over 3 minus 2t squared plus 3t from 1 to 3 plus t cubed over 3 minus 2t squared plus 3t from 3 to 5. So far, so good? We able to get to this point? So they're all the same antiderivative. So you can probably come up with more efficient ways to find the actual answer. So if you plug in, you get 1/3 minus 2 plus 3 minus 0. So that's 4/3. So for the first second, travel a distance of 4/3 units. Now here you plug in, and you get 9 minus 18 plus 9 minus 1/3 minus 2 plus 3. So minus 4/3. That gets you to plus 4/3. The third part is annoying. 125 over 3 minus 50 plus 15 minus 9 minus 18 plus 9. That's 20 over 3. So you should get a total distance of 28 over 3 units. Feet, meters, whatever. Okay? Alright, that's enough.